With the data set that we have from the U.S. Energy Information Association, we can ask several different questions. Another question that we might be interested in asking is, what is the duration of electric power outage for outages occurring during the day with 99% confidence? Okay, so we want a 99% confidence interval for the mean duration of outages that occur during the day, that are initiated during the day. So we first take a look at our AM column. Those are the outages that occur during the day if AM is equal to 1. And we see that there are 14 outages that occur during the day. Okay, so our sample size now is just 14. We're focusing only on those 14 outages that occur during the day. Okay, so again, we can apply our average function and our standard deviation function just to those 14 observations in the duration column. Okay, we know that we want a 99% confidence interval. Okay, so we've got alpha is 0.01. If we implement that average function just for those 14 observations that occurred during the day in the duration column, we get y bar equals to 50.67. And if we take the standard deviation, again, just of those 14 observations, we get that the standard deviation is 55.78. Okay, again, these are in hours. Okay, and we know that we had, again, 14 observations. The sample size is 14. Therefore, degrees of freedom n minus 1, 14 minus 1, which is 13. So we have a problem here with 13 degrees of freedom. So with 13 degrees of freedom, we can probably use either the t-table, go down to the 13th row, over to the 0.01 column, 0.01 in the upper tail, and we would get a value of t associated with degrees of freedom 13, alpha over 2, 0.005 in the upper tail. We should get a value of 3.012. Okay? Also, if we wanted to, we could use the t-inverse function. Okay? We would have to read in the two-tailed probability. Here, two-tailed probability would have 0.005 in each tail. That is 0.01. And degrees of freedom 13. Okay, if we get that, if we do that in Excel, we get the same answer, though we probably have several more digits after that. Okay, or this might be rounded up a little bit. Okay, so now we have everything that we need to calculate this confidence interval. That confidence interval, again, is y bar plus and minus t for degrees of freedom 13, 0.005 in the tail, times s over root n. Okay, that is y bar 50.67 plus and minus t 3.012 times s 55.78 divided by root 14. Okay, we had n equals 14. So we can calculate this out. This is just arithmetic at this point. Okay, getting all those numbers right in the first place is the first step, and then getting the arithmetic is easy after that. We have a lower bound of 5.77 and an upper bound of 95.57. Okay, and those are in hours. Okay, so what are we saying here? We have a 99% confidence interval for the true mean duration of outages that were initiated during the day. Okay, and this confidence interval, we would read that as we're 99% confident that the true mean duration of outages initiated during the day is between 5.77 and 95.57 hours. Okay? So, you know, we might want to ask ourselves some questions here. For example, what makes this result different from the result that we saw previously? That is, if we only focus on those 14 observations that were initiated during the day, how is that different from all observations, all 38 observations? Well, one, we see that the mean is larger, okay? And also, we see that the variability is larger. It's much larger than if we were to look at all of the observations. So maybe there's something about outages that are initiated during the day that have different characteristics. They have a longer mean duration, and they have a more variable amount of duration. Okay. Also, what makes this a little bit wider? Well, remember, that the confidence interval is a function of the point estimate plus and minus the margin of error, where the margin of error is a function of variability, sample size, and confidence. Here we have more confidence. Previously, in the previous example, we wanted a 95% confidence interval. Here we want a 99% confidence interval. So we are widening the confidence interval. Okay, so that's another reason why this thing is wider than the one we saw previously. Also, sample size is smaller. Okay, so we're dividing here by a smaller number. That widens the confidence interval. So there are several reasons why this confidence interval is a little bit wider than the one we saw previously. Smaller sample size. Okay, we have less belief about shrinking that confidence interval because we have a smaller sample size. We have fewer observations to go on. The variability larger, and we want a larger amount of confidence. All of that makes that margin of error bigger. Therefore, this wider than the previous example we saw.